So welcome back, guys. Good afternoon, everyone. This is Divine Occurable. So please kindly subscribe to our YouTube channel. So today I'll be talking on isotopy in chemistry. So first define what is isotopy. It is written there: isotopy is the existence of two or more atoms of the same element. Take note of the word the same element, having the same atomic numbers but different mass number. Thank God. Let me just write it here. But different, pardon my writing, but different mass numbers due to the difference in the number of neutrons in their various nucleus. So isotopes have the same atomic number but different number of neutrons. I just hope this camera is clear now. So that is it there. So what do we mean by atomic number? Let's say, example, this is an atom, this is atomic number, this is mass number. So this atomic number means the number of proton or the number of electron in a balanced reaction. So if for instance 8 is here, it means if the atomic number is 8, it means what? There are 8 electrons and 8 protons. But this Z is representing mass number. To get this mass number, you will add atomic number plus the number of neutrons. So how do we get neutrons? We get neutrons by mass number minus atomic number. So let me now give you example of isotope. So what this isotope is, isotope have the same atomic number. That means they have the same this one but have different mass number. Why do they have different mass number? Because of the number of neutrons. So let's go to this example. They said hydrogen, for instance, has 3 major isotopes. The first one is called protium. It has 1 atomic number, 1 mass number. The second one is called deuterium. It has 2 mass number, 1 atomic number. The third one is called tritium. It has 3 mass number and 1 atomic number. So if you notice, these 3 hydrogen have the same atomic number. What does that mean? It has the same number of proton and the same number of electron, 1 1 1. But their mass number is different. This one is 1, this one is 2, this one is 3. So why is it different? It is different because of the number of neutrons. So what did I tell you the number of neutron is? Let me write it here again. Neutron equals to mass number minus atomic number. So to get the neutron in this place, it will be what? What is the mass number here? 1 minus 1, which is 0. So in this isotope of hydrogen, the neutron is 0. And that is for protium. In deuterium, the mass number is 2. 2 minus 1 is what? 1. So it has atomic number of 1. It also has the neutron of 1. Then this third one too has what? The same atomic number. But what is the mass number? 3. So to get the number of neutron is 3 minus 1, which is 2. So the isotope of the third one have 2 neutron. The second one have 1 neutron. The first one does not have any neutron. So do you get it now? It has the same atomic number but different mass number. Why? Because of what? Different number of neutron. So let's go to other examples of isotope. Chlorine, for instance, has 2 major isotopes. So what is the mass number, atomic number of chlorine? See it here, 17 17. But they have different mass number. Why? I told you before, it's because of the number of neutrons. So how do we get the number of neutrons for this first one? What is the mass number? 35 minus 17. That is the atomic number. The number of neutrons for this one is what? 18 neutron. Then the number of neutron for this second one is mass number minus atomic number is what? 20 neutron. So you notice they have the same atomic number but different mass number because of the number of neutron. The same thing with carbon. Carbon has 3 major isotopes. This and this. So what is the number of neutron here? 12 minus 6, it will give you 6 neutron. 13 minus 6 will give you 7 neutron. 14 minus 6 will give you 8 neutron. So the difference in the mass number is because of what? The number of neutron. So then I say take notes. Oh, this camera. I just hope you can see it. Yes. Note, this 14 isotope of carbon is used in archaeology for dating. So they can ask you in JAMB, which of the following isotope of carbon is used in archaeology for dating? You pick which one? 14 carbon. Oxygen has 2 major isotopes. So the first one is 16.8, the second one is 18.8. So how do you get the number of neutron? Mass number minus atomic number. 16 minus 8 will give you what? 8 neutron. Yeah. 18 mass number minus 8 atomic number will give you what neutron? 10 neutron. So if you notice from all the example, the atomic number is the same. And I told you the atomic number is the number of proton. It's also the number of electron in a balance equation. But the number of neutron is this up minus this one. And so you are asking, why am I even talking about neutron, electron, and proton? Let me just write it here. Atom comprises of major 3 subparticles: proton, neutron, and what? Electron. The proton and the neutron form together what we call nucleus. So this electron it moves around the nucleus, but that is another topic. Don't let me digress. So we now say note, isotopes of the same element, isotopes have the same chemical properties. Do you know why? Because they have the same atomic number. So oxygen 816 have the same chemical property as oxygen 818. Why? Because they have the same atomic number. And electron is the one responsible for the chemical properties of a reaction. And I told you that this atomic number is the number of electrons. So if the number of electrons are the same, it means they have the same chemical properties. So they can ask you, which of this is correct? Isotopes have the same chemical properties. You know that one is correct, because they have the same number of electrons, but they differ. Why do they differ? We have been talking about this since, because of the number of neutron. 12 minus 6, 6. 13 minus 6, 7. So take note of that. Then from isotope, we have what we call relative atomic mass. Relative atomic mass is the average mass of all isotopes of an element. So to solve it, you put relative atomic mass equals to the mass of the, let's say if we want to find the relative atomic mass of chlorine, the isotopes of chlorine, you do the mass of the first chlorine. What is the first chlorine? 1735 times the abundance. I'm going to show you what this means in the next question. Times abundance of the first chlorine. You will times it together plus the mass of the second chlorine. What is the mass of the second chlorine? 37 times what? The abundance of the second chlorine. Once you do it like that, you get your answer. So let's go to the question. So this is the formula. Relative atomic mass is equals to what? The mass number of isotope 1 times the abundance of isotope 1 plus mass number of isotope 2 times what? Abundance of isotope 2. Continue like that. If it has more than 2 isotopes, you continue like that until the last one. So let's now go to an example. So see this example now. They say calculate the relative atomic mass of chlorine if it occurs in 2 isotopic forms: 3517 chlorine and 3717 chlorine, with abundance of 75% and 25% respectively. So what is the first mass? Let's write it here. The mass of isotope 1 is what? Check it, see it here, 35. You are using the up one. Oh, notice I told you that the atomic number is the same, so you are not using this one to solve. 35 times abundance. Remember from our formula, mass times abundance, plus what is the second one mass? 37 times abundance of the isotope. So let's now go to the question. They said 75% and 25% respectively. It means 75% for this one, 25% for this one. So what is our formula? What is the mass of the first isotope here? You write 35 times, what is the abundance? 75%. What does it mean by 75%? Anytime you see percent, you know it's what? Over 100. That is what? 35 times 75 over 100. You do it like this, bracket, so that you don't do mistake. Plus, what is the mass of the second one? 37 times, what is the abundance? 25%. 25% means what? 25 over 100. Once you press your calculator, it will give you this as final answer. So the relative atomic mass of chlorine is 35.5. But sometimes in question, they might not give you in percentage. They will give you in the abundance of 3:1. So how will you go about it if it's 3:1? What will you do? You do what? If it's 3:1, you add this two together. What is 3:1? You first come and do like 3 plus 1 equals to 4. So the first one will be what? 3 over 4 abundance. Then the second one will be what? 1 over 4. If you do 3 over 4, notice it will still give you 75%. If you do 1 over 4, it will still give you 25%. So sometimes they don't give you percentage, they give you in ratio. But if they give you in ratio, you add the two together, then you use this one over the ratio times the mass of the first one, then use the second one of the total ratio times the what? Abundance times the mass of the second one. So let's go to this question. Say the RAM of boron is 10.2. RAM means relative atomic mass. If the element occurs naturally in two isotopic form, 10.5 boron and 11.5 boron, find the abundance. So they're asking us to find the abundance. So we will now write, this is where you need to know mathematics. Let the abundance of the first one be what? A1. Remember our formula. Let me see it here. Mass of the first one times abundance of the first one plus mass of the second one times abundance of the second one. So in the question, they're asking us to find for the abundance. So we are going to write A1. That means we don't know the abundance. But let's check something from this question. If you notice, they say the first one will have what? Abundance of 75%, and the second one have abundance of 25%. It means anytime you are solving isotope together, the two abundance must give you 1. So how do I know that? 75% plus 25% will give you 100%. I told you percent means over 100. 100 over 100 will be what? 1. So take note of this. Anytime you are solving for isotope, the two abundance, when you add it together, it will give you 1. So we'll now come to this question. Let the abundance of this first one be abundance 1. So how will we now get the abundance of the second one? It's very simple. The abundance of this one, that is abundance of 2, is what? 1 minus abundance 1. How do we get 1 minus 1? If abundance 1 plus abundance 2 will give you what? 1. Then abundance 2 will be what? 1 minus abundance 1. You carry it here. That is simple collecting of like terms. So now, why are we putting 1 minus abundance 1? So that we'll be able to solve it. So instead of writing abundance 2 here, we'll just put what? 1 minus abundance 1. So let's now go back to our formula. Relative atomic mass is equals to mass of the first one times abundance 1 plus what? Mass of the second one times abundance 2. So what is the relative atomic mass in the question? 10.2 is equals to what? 10.2 is equals to 10. 10.2 is equals to 10. This is the mass of the first one times abundance 1. Remember, we're looking for the abundance, so we don't know it. Plus, what is the second mass? 11 times abundance 2. What is abundance 2? Instead of writing abundance 2, remember, I said abundance 1 plus abundance 2 will give you 1. So to get your abundance 2, it will be what? 1 minus abundance 1. So let me just make this one simple for people that are not really good in maths. If they say Divion and Dominion, we share 10 naira. Divion DI plus DO, we share 10 naira. So what will be Dominion money? Dominion money will be what? 10 naira minus anything I collect. So let's say that I collect 5 naira. Dominion money will be 10 minus 5. If I collect 4 naira, Dominion money will be 10 minus 4, which is 6. So that's what we come here. Abundance 1 plus abundance 2 will give you 1. So to get your abundance 2 is what? 1 minus anything that is abundance 1. So that's how we get this. So we'll come back again. 10.2 is equals to what? 10 abundance 1 plus. We will now put this bracket. 11 times 1, 11. Plus times minus, minus. 11 times abundance 1, 11 abundance 1. What did I write here? Correct like terms. It means number will go and meet number for easy solving. So let's now come to this place. 10.2, let me just show you. 10.2, when plus 11 will come here, to change to what? Minus 11. That's how we have it here. 10.2 equals to 10.2 minus 11 is equals to 10 abundance 1 minus 11 abundance 1. So how do we get this one from? When this plus 11 come here and change to minus 11, what will be left here is 10 abundance 1 minus 11 abundance 1. So 10.2 minus 11 is what? Minus 0.8. If you are not too good in mathematics, not to make mistake, you can use calculator. Then 10 abundance 1 minus 11 abundance 1 is what? Minus abundance 1. It's just like saying 10x minus 11x is what? Minus x. So this s is representing abundance 1. So instead of, if you know abundance 1 is going to confuse you, you can just say let the abundance of the first isotope be x, but I'm using a so that you know that I'm talking about abundance 1. So 10 abundance 1 minus 11 abundance 1 is what? Minus abundance 1. Then 10.2 minus 11 is what? Minus 0.8. Minus cancel minus. So abundance 1 is 0.8. Then I told you, remember from our formula that abundance 2 is what? 1 minus abundance 1. So abundance 2, this abundance 2 means the abundance of the second isotope, which is this one, is what? 1 minus abundance 1. That is 1 minus 0.8 equals to 0.2. Remember, this is for abundance 1, this is abundance 2. But if you check this question, our abundance was given in what? Percentage. So after getting your 0.8 and 0.2, you convert it to percentage. How do you convert it to percentage? 0.8 over what is the total? I told you that anytime we're solving isotope, the abundance of all the isotope must be equals to 1. So that will be what? 0.8 over what is the total isotope? 1 times 100 equals to 80%. Then 0.2 over what is the total isotope? 1 times 100 equals to 20%. So the first isotope has 80% abundance. The second isotope has 20% abundance. So you are wondering, this is the answer. If you leave this answer like this, is correct. If you leave this answer like this, is correct. But sometimes I'm telling you, because JAMB is objective, so they can change it from 0.8. You convert it to what? Percentage. To convert to percentage means times 100, 80%. 0.2 times 100, 20%. So if you understand this question, you can watch it again to understand. Now solve this question and drop your answer in the comment section. The two isotopes of an element 2010Y, so this is isotope 1, and 2210Y exist naturally in the ratio 3:1. I mentioned something like this here. I said sometimes they might not give you percentage, they'll give you a ratio, and I told you how to go about it. But in case you still have difficulty, you can say it in the comment section. I'll reply. Respectively, what is the relative atomic mass of Y? So this one now, they gave you the abundance, but you're looking for the relative atomic mass of Y. You are going to solve it like this one. But this question, take note, is different. They gave you the relative atomic mass. You are now looking for the abundance. So I hope you should be able to solve this question. Drop your questions, your answer in the comment section. Then if you want to join our free tutorial for science students that are writing UTME next year, then message this number on WhatsApp. Just go straight to the point, please. I do have loads of messages. Just mention, say, good afternoon, sir. My name is so. I want to join your free science tutorials. God bless you. Please, if you know this video was valuable to you, kindly subscribe, like, and comment. Thank you.